Hello, and welcome to a short video to describe and demonstrate VpK, Visual Parsed Kubernetes. What is VpK? It's a tool that was created as a result of needing to understand and visualize what is defined in all those Kubernetes configuration files. Let's take a quick look at the VpK architecture. VpK is comprised of two primary components. The first is a UI application running in a client browser. The second is a server component running on the same machine as the browser or on a different machine. Typically, I install it all on a client machine. I like using the tool from my own desktop. What you'll also need is a running instance of IBM Cloud Private or configuration files, the YAML files that are used to define Kubernetes. What's it take to get started? Well, there's a few simple prerequisites. A web browser that supports HTML5. Since the application is written in JavaScript, it uses Node.js for the server component, and this server component actually does the processing to communicate with the running instance of Kubernetes or reading the file folders, and it uses the kube control command to communicate with the server. And also npm. This is required so you can install the packages required to run the application. How do you get started? Well, you simply clone or download the source code from this GitHub link. Let's get started by opening a terminal session and cloning the Git repository. I've already created this directory called R1. Now I'm going to go ahead and clone the Git repository. So you can see it cloned very quickly. Now let's look at what was created in this directory. You'll see that there's a subdirectory called VpK. Let's go ahead and cd into that directory. And let's also look at the contents of that directory. This is the root directory for the VpK application. Since it is a Node.js application, there is a package.json file. Now note that there is no node modules directory, so the first thing we're going to need to do is to install the dependent node packages. And we do that by typing npm install. The required packages are now being installed. This typically takes just a few seconds, and the application has been installed on your desktop. Now again, remember, you needed to have npm and node prerequisite installed for this to work. All right, the next step is we're going to go ahead and start the server. The way you do that is type node server.js. This will actually start the application. And quite a bit went on, but let's go ahead and scroll up in the log here, and you'll see that there are a lot of information or a lot of categories with 0 beside them. That 0 indicates that you did not start the application with a startup parameter. So I'm going to go ahead and exit the application, and you can just Control-C to get out of it. But let's point it to a directory. Now I have a directory on my machine called cluster, and this directory contains several YAML configuration files. Now when I go ahead and hit the enter key here, the next time we see something similar to this, there will be counts behind many of these values. I want to go ahead and start the application. Note that the server is running on port 4200. I've already got this coded in here, so let's simply hit the enter key. And I'm going to leave this console in the background running so you can see that there's activity as we do some things, and you can use this log file from the console or the terminal session to help you understand what's going on. So the first thing, let's talk about the UI. You can search by namespaces and by kinds of resources that were found when the YAML files were parsed. You can see we have several different types of resources out here. Any resource that ends with a parent u parent is a user-defined resource and is not a true resource that is defined by itself within Kubernetes. It may be a subparameter of a existing Kubernetes resource kind, but the parent U parent means user-defined, and these user-defined categories help us search and find information. Now, also, if we look at the namespaces, you'll see that there were multiple namespaces. Cluster level definitions, default namespace, kube system, not defined namespaces, and a services namespace. Now, the directory where I read this information from is the cluster directory. Now, if I go ahead and select a type of resource that I'd like to search for, let's select stateful set and press the search key. You'll see that there were 6 different results. Now, if I wanted to view this, and this is the visual component of VpK, I simply select the View button on the right-hand side of the individual item. The information will be drawn, and let me scroll down to that. This is the information, a visual representation of what was defined within that Kubernetes stateful set within the kube system namespace. This is a stateful set is for the zookeeper, and you'll see there's a volume claim template, tolerations, node selector, container, lots of several subcomponents within the container. Now, as you mouse over these, you'll notice that there's a small pop-up. The value that you see there is what is used when you click on that item. That value will be highlighted in green within the actual YAML definition file. So let's go ahead and click on this volume claim template. You'll see that this is information contained within a zookeeper YAML file. Now, this was a multi-part definition file because you can define multiple kinds within a single definition file. This was the 4th part in this definition file. And let's go ahead and scroll on down till we see the green highlighted text. This zk-data is what it was searching for. You'll see that it was found within the volume mounts, but this was a volume claim template. And this is the information that relates to that link. Let's go ahead and close this. And let's just navigate and try a few other things. Let's just look for tolerations. You'll see there's the tolerations that were defined. Now, you don't always have to click the close button here at the bottom. If you simply click outside of the white area, it will close that pop-up. But let's go ahead and click on the container port here. So that's the way you could actually visualize what is within a YAML definition file. As soon as you select any one of these boxes, the actual definition file is opened. You can see here I clicked in the gray area, which is Zookeeper, and every place the name Zookeeper was defined within the configuration file, it's highlighted with a green background. Let's go on back up to the search. Now, the toggle buttons here allow you to close the section. If I wanted to close the search results, I could. If I wanted to close the display results, I could. And the same thing with the search filter. Well, let's go ahead and select a different type this time. Let's go ahead and select let's select secrets. And let's go ahead and search across all namespaces. We'll hit search. We'll see that there are several search types or several items in the search results. So let's go ahead and select multiple items. Now, I'd like to look at all 4 of these results: platform kube secrets, platform MariaDB credentials, platform OIDC credentials, and the OAuth client secret. Instead of selecting the view button on the side, I want to view multiple results. That's why we selected the check marks here. So press the view multiple. The previous diagram was erased. It's no longer there. And now you can see the results. You'll see the first one, the platform kube secrets. This secret is defined within one file. It's the platform-api.yaml. You'll see the platform MariaDB credentials are defined in two places within this file. And then you'll see that the platform OID credentials are used in several different files. This really helps you understand what would happen if you decided to change that secret. So let's go ahead and scroll back to the top and let's look at this one here. I'm going to, for the platform OID credentials, I'm going to look at the daemon set defined within the catalog.ui.yaml. And here were the secrets were defined. So that platform OID credentials were defined at this point. Now if I go ahead and select this second file, and the grouping of resource kinds are grouped inside a dashed box. You'll notice there were two daemon sets here. Now this deployment for Kibana is in a box by itself. Here's another two deployments down here within the dashed box. But let's pick this one for Kibana. And we'll see that there's that OID credentials secrets definition. I want to go ahead and return to the search capabilities at the top. And let's explore these search capabilities a bit more. As I had indicated before, you can select a specific namespace. Let's still stay with all namespaces, but let's go ahead and select all kinds and then do a search. Now, what happens here is every type of resource that's defined within the configuration files is displayed in the search results. And there are literally hundreds of results. Let me scroll back to the top. This large list of results becomes somewhat difficult to deal with. And that's why you would want to start to use this additional search parameter. So let's look for any type of definition that is related or has information related to the definition for zookeeper. So I'm just going to put zoo in and I want to search again. Now the results are a much smaller subset. You can see that it's not hundreds, it's just a few results here. And each one of these has something named or has the parameter zoo within the name definition. But what we see here is we see commands, container, environment, labels, liveliness probe, pod distribution budget, readiness probe, selector, service, and a stateful set. These are all of the resources or kinds that were defined with zookeeper. So if I wanted to look at all of those properties, I could select all of these and then view multiple. Again, the previous definitions will be cleared, and you can see here that now we have the zookeeper command. So the command definition, if we look at this, we'll see that it's contained within this configuration file, and this is command is a subparameter for containers. The same thing with container name, environment, labels. You can see labels were associated with multiple attributes over here, or multiple kinds. And then the liveliness probe, the pod distribution budget, readiness probe, the selector, again a selector, and then we have service definitions, and then finally the actual stateful set. So this is a real easy way for you to filter and look at components that cross multiple categories or kinds. So you can see here there are several different kinds that were comprised within this directory, the /cluster directory that I used when I restarted the server component.